My name is Nathan Lovegood, and the project that I made for the individual project is something called the pH Organics Fertilizer. Just a little background information. I did the country of Bolivia. I was primarily looking at the rural areas where malnutrition was a huge problem throughout along the Andes Mountains, throughout the entire countryside of Bolivia. It's actually one of the worst death rates in the world, 21st in the nation actually, followed by, or it's directly behind countries like Haiti, which is first, and Guatemala, which is 13th. And like I stated previously, it's mostly in rural Bolivia. It primarily affects toddlers and pregnant women because those are the people that need the most amount of nutrients in order to develop right. Pregnant women need those nutrients in order for the babies to grow properly, and the toddlers, if younger children, if they don't get the proper nutrients, then their overall development could suffer. There have been some solutions that actually go after this malnutrition, such as nutrient immunizations, different vitamins, therapeutic foods, but none of them have proven to be a substantial factor to helping out with malnutrition. So the problem, malnutrition in Bolivia is one of the worst in the world. The economy kind of is a problem there too, which is why they aren't able to afford very good health care, or they're not able to afford anything to really benefit them, because $6,000 gross domestic product per capita, so it's not very much at all whatsoever. The nutrient immunization, vitamins, therapeutic foods. There have also been government loans that have been given to farmers to help crop yields and help them grow more food, but then again, farms have to pay that back, which puts them in debt. And the main focus of this entire project is for those that suffer most, such as the farmers and the toddlers and the pregnant women. So the three main objectives to this product is that the chemical solutions that are being used for this fertilizer, they can't harm the plants. Because they harm the plants, then that completely backfires the entire project. As well as supposed to provide a healthy atmosphere for the environment in order to prosper. So it's more beneficial to the local environment, which is going to help out local vegetation. And it should also be easy to use, because if it's too complex, no one's going to use it. So methodology, there are three solutions that are kind of out there but haven't really been tested into. First one's a color changing soil. Basically, like in titration, whenever you use a chemical solution and you drop an acid into, or you drop a certain chemical into a little solution, it changes color based if it's acidic or based on the pH. This soil or fertilizer does the same thing. As you dump this fertilizer onto the soil, it would change colors briefly based on the acidity of the soil itself. It can turn a little more pink if it's more acidic, or blue if it's more basic, but nothing really drastic there, because if the soil isn't exactly where you want it, well then it just identifies and there's just no point in it. The second solution is the packets of chemical solutions, which are just, you just take a little bit of, there's a certain chemical within a little packet, kind of like what you see in the sugar packets, and about the same size sugar packets in like restaurants. Take that, dump it on the soil, or you get a little cup of soil, you dump it in there, and it would fizz, or it would have some sort of chemical reaction to notify the pH. And the last solution is a pH meter / reader. You stick it into the ground, and it will digitally tell you how how acidic the soil is. Going with the packets of chemical solutions was the product idea that was used for this fertilizer. The three main design criteria that we had for this fertilizer was it was supposed to benefit the environment, so that way not only could the crops or the local other plants prosper, but the groundwater wouldn't be contaminated, so there wouldn't be any pollution, less chemicals onto the plants as well, so when they're consumed by humans, they don't make other people sick, and it helps the local vegetation prosper as well. The second is increased plant growth, so you reapply that nutrients into the ground, so that way the crops are able to get the nutrients that they need to grow to their fullest potential. And once again, it's supposed to be easy to use, because if it's too complex to use, especially for poor farmers who don't have necessarily the education that are able to read or follow complex steps, it'd be much more easier for them to use. So the use of household items would be used to test the pH. In this case, we use vinegar to test if it's basic, and baking soda and distilled water to test for the acidity, or test for the acidity of the soil in itself. As you can see on this chart right here, this is very useful because common household items aren't very expensive to produce, and this gives you the exact nutrient availability, or an estimated nutrient availability based on the pH of the soil. So as you can see, the closer it gets to a neutral, which is about a pH of 7, the closer it gets to neutral, the more available these nutrients are. So these factors here, the vinegar, the baking soda, and distilled water, will be able to let you know if the availability of your nutrients are running low or if they're exactly where you need them to be at. So as far as results, the first part that was developed was the specifications of the design and the summary of it. There isn't really necessarily anything we need to change as far as the packaging. The only difference is how do we apply the solution packets into the fertilizer. So what was developed was there would be 3 basic sizes as per norm with every fertilizer. You have a smaller bag, which is 25 kilograms, regular bag, which is 40, and a large one, which is 50. Because we're adding these little packets in there, there's going to be a little pouch within them as well. So inside of not only this bag is the fertilizer, but a little pouch that holds each of these different packets. So we expanded the size a little bit so it's able to comfortably fit within the bag with the fertilizer. How you're able to tell if it's working efficiently or if the pH is where you need it to be at, you look at the amount of fizzing. So as you dump the fertilizer, or as you dump the baking soda and distilled water to test the acidity, you look at how much it fizzes, that chemical reaction. And if it were to fizz a lot, that'd tell you that it's very acidic, roughly at least 5 or even lower, closer to 4. Or if it fizzes a little bit, it gets closer to a more basic solution. And if you really are not seeing very much fizzing at all whatsoever, that's where you apply the vinegar, and the vinegar will test how basic the soil actually is, and it's vice versa. So one of the things you want to look for, or one of the things that you can test the pH for, is the hydrogen ion concentration within the soil for this pH. And that's where we use this equation to test the pH. We have pH is equal to, it's a log-based function, log base 10 of the hydrogen ion concentration. And as you can see, if we use a pH of 6, because since that is more ideal, then that'll give you the hydrogen ion concentration. You want that to be around 1.0 times 10 to the negative 6 moles. And because you ideally want a pH between 6 and 7, your ideal molar concentration is going to be in between 1 to the negative 7th and 1 to the negative 6th moles. So once again, depending on the amount of fizzing, it'll tell you what the pH of the soil is at, and where if you're able to put your plants into the soil for them to grow efficiently, and based off the pH, you'd be able to tell the hydrogen ion concentration within that soil, and if it's best able to help your crops prosper. So looking at the materials, the normal composting collection materials, there are different ways, different ingredients, different components to make an organic fertilizer. But the overall cost per ton, if you were to collect that, would be about $70. The plastic that we would use for the bagging, as far as for the pouches, the little packets, and the fertilizer bags, per 2,000 square feet would be about $5. Vinegar per gallon about 30 cents, baking soda per pound 20 cents, distilled water per gallon 4 cents. So overall, if you were to put all this stuff together, it would cost no more than $1 to produce something like this, which is good because it means it's cost efficient, which means you're able to sell it for a smaller price whenever you go into countries like Bolivia, and the poor farmers are actually able to afford such a product to help them prosper. And this is a one and done kind of solution. Once you use the fertilizer, you can't scoop it back up because you apply the fertilizer. It's the same thing as normal. The nutrients go in the soil. But the packets, though, you don't have to use all the packets. There's more than sufficient amount in there for the packet. You can save the packets for future testing. And no maintenance is really required. But because of the plastic that the bags and the packets and the pouches are made of, plastic number 6, it allows for recycling. So that way, instead of taking it through in the trash for it to go in a landfill or an incinerator, you can recycle it so it turns into stuff like food trays. And it will actually provide an economic boost over time because the increased crop yield means that the farmers will have more to sell, which means they're able to raise more money, which means it should stimulate their families, income. And not only does it allow for the most crop yield, but it also replenishes the soil and benefits the surrounding environment. And society actually benefits from this economically and culturally because it's all natural components. You don't have to worry about throwing in a landfill or anything. It'll benefit the environment and the local economy very well. As you can see here, the organic versus the inorganic, there are a lot more pros to the organic than the inorganic in terms of crop production, soil biodiversity, carbon, CO2, sequestering, energy to produce, all that. So in conclusion, the environment can normally benefit from day-to-day stuff like riding a bike or recycling. But this will be able, the pH will be able to tell you how available the nutrients are for your crops. Farmers are also able to sell this to make more money, and it can stimulate their income. And overall, this product can stimulate the economy because once you start raising the local income of some, others can benefit from it too.